Okay, so part one, number four. Uh, Three charges of equal magnitudes are fixed in place and equidistant from each other. What is the direction of the net electric field due to the three charges at the point shown below, located at the perpendicular bisector of Q2 and Q3? So essentially, what we're trying to find the direction of the electric field due to these three charges. And we know electric field is a vector, and so by superposition, we can actually add, to find the net electric field and its direction, we can add up the components of each of the electric fields here due to the charges. And so um, some things to note as well. We know that the distance between these charges is the same between Q1 and Q2, it tells us in the problem. And then because this is bisecting, the distance from this Q2 charge to this point is the same. So this right here is the same as this distance. So the magnitudes. Okay, so then now let's go ahead and look at what the magnitude, or let's look at what the electric field is doing from this charge. And so what it's doing from that charge, and we'll call it E3, from Q3 is in this direction. This is, actually, let's do it with this marker. This is E3. And then from this charge, I can take that out, we don't really need that necessarily. The E field is going to be towards the negative charge in that direction. Oops. Okay. So now, if we draw the components, and that's E2. So this is E2. Well, we know that the magnitude of E2 and E3 are equal. And that's because the distance between them and the point are equal. So the distance from Q2 and E is equal to the distance from Q3 and the point E. And so what we can say is, if we break this into E3 into its components, here's E3x, here's E3y, and then if we break this one into its components, which is E2x, and this one down is E2y. Notice the y components are going to cancel because they're equal but opposite direction. Then for the x components, they're collectively going to add and point towards the left. Now, that's if we just had these two charges. Now we need to look at, for this positive charge, the electric field. Well, we know the electric field from positive charges points away. And so if we add that on to here, it's going to point in that direction. So it's essentially going to go up. Now the X component going that way is going to take away from this left component, but it's not. So if we look at the components here, for let's call this is E1, E1. The X component is going to be small because it's a lot further away, so the overall magnitude is smaller. But the Y component, E1Y, will push it up. So we know that the collective component X components of these two charges is for the electric field will push it to the left. This one will subtract somewhat, but it's not as large, so it'll still be towards the left. Now, from this charge, it'll still have a Y component pushing up, and so nothing cancels out there. We've already accounted for these, so therefore, overall, the direction of this electric field will be to the left and up.